Hi, my name is Gerard O'Connor and I'm part of the RespiceSME Coordinated Support Action funded by the European Union and the Photonics 21 Public-Private Partnership. We have developed a value chain analysis tool which we hope will strengthen the integration of photonics into European industries by identifying the ventures most likely to be successful. In this presentation, I'm going to give you a little more detail about what the tool does and how it works. Our mission has been to develop an analysis tool which allows researchers and small to medium-sized enterprises evaluate a photonics concept in a new field of application. We want to exploit the leverage effect of photonics in a non-photonic sector for such photonics-based enterprises. The questions that arise when you try to develop a photonics concept and apply it in a new field are: 1. How does a photonics SME get to know the non-photonics field of application? 2. What is the value of the photonics product concept? 3. Where should future R&D activities be directed? And 4. What is the innovation potential of photonics in the enabled field of application? Our vision is that by analysing the value chain, we can supply some important answers. The approach is centred on evaluating specific value propositions. Value chain analysis identifies stakeholders, both competing and collaborative. By placing these stakeholders in a structured framework, we can come up with a highly differentiated value chain, one that can be most competitive. Gaps in the value chain where there are no stakeholders are potential weaknesses and threats to the product development. We must analyse these very carefully. In addition to the value chain representation, we believe we can undertake a system model analysis. This can optimise the impact of the photonics concept. Scalable innovation depends on well-synthesized systems, so the system model is an important aspect of our analysis. The value chain analysis tool is best completed by the researcher or the engineer who has conceived the product concept. That is because they know the technology best. We also believe it should be done immediately after the product concept is conceived and prior to any market feasibility studies. The iterative application will also yield better results. Our value chain analysis consists of 5 steps. The first step is to define the product concept. The second step is to identify the stakeholders. The third step is to assess the technology readiness level. The fourth step is to assess the innovation potential. And the fifth step is to progress using the system model. Over the next few slides, I will describe these steps. So in step 1, new photonics products can be generalized into 2 categories. New photonics products for use within a photonics field, or new photonics products for use outside the photonics field. Our value chain analysis is optimized to investigate the application of photonics in a non-photonics field of application, one in which the photonics expert or researcher is not very familiar. We define the system model for the new product concept from the outset. The system model pieces together the broader technical ecosystem within which the new product will operate. In general, all such systems follow a similar pattern, as is seen here on the left. The new product is typically referred to as the tool, the element that produces the main output from the system. Other elements such as the source and the distribution create and deliver the usable ingredients or inputs for the tool to function. These inputs in their usable form are called package payloads. The interactions between these elements are orchestrated by the control. A fully developed system is essential for a competitive and scalable product concept, capable of embarking on the S-curve trajectory. System elements represent exploitable and controllable parts of the broader technical ecosystem. The next step in identifying our product is to identify the technical value chain. Value chains have been extensively developed for particular geographical regions or particular segments of technology. Our approach is different. Our value chain is focused on the new product concept. Downstream of the product is the application field. The applications connect with the end user products, and they with the societal challenges. On the upstream side of the product, the technical value chain has materials, processes, components, subsystems, and systems that provide technologies into our product. Understanding and articulating the value chain is a vital step for developing the new product concept. The final step for defining the new product concept is identifying how it aligns with local and regional strengths. Here we think about how the regional ecosystem is centered around the photonics product concept. We consider what input factors the photonics concept can leverage in terms of local resources, maybe human or infrastructural resources. And how do these input factors connect through the photonics product concept to the local demand conditions? We also consider how related and supported industries in the region can also contribute to our product development. We're particularly interested in what are the sources of local strategic rivalry that can really encourage the development of an internationally competitive new photonics product. The next stage of our value chain analysis is the stakeholder analysis. For stakeholder analysis, we identify and categorize relevant stakeholders for the new photonics product concept. Rival stakeholders are identified following the thorough categorization of the product in step 1. These are the stakeholders who compete directly with our product, either with a comparable product, which are a similar tool, or with substitute products, which would usurp key elements of the system, or as new entrants who would disrupt the entire system. On the applied side, the stakeholders who are interested in the new photonics product as a solution to one of their needs, either through an application of the new product or by using the new product to enable a new end-user product to address a societal challenge, are analysed. On the supply side, we identify stakeholders who can provide technology into our product concept, and they are the supplier stakeholders. So for each of those stakeholder categories, and for each of the stakeholders in those categories, we assess the stakeholders in terms of their activity, their technical affinity, whether they're conflicted, and if they're engageable. These qualities are assessed and numerated to produce a stakeholder relevance score. Unique to our tool is the method we use to find stakeholders. We use structured keyword-based searches on strategic websites to identify relevant stakeholders. We data mine cluster websites, RTOs, educational institutes, and other industry organisations using custom search engines. We then identify specific value propositions linking each stakeholder to the product concept. On the applied side, we ask, how does the photonics product add value to the stakeholder? The specific value proposition is core to our analysis. The value proposition connects the different stakeholders together and is the foundation for the rest of the analysis. In step 3 of our value chain analysis, we assess the technology readiness level. The motivation for doing a technology readiness level, or TRL analysis, is as follows. TRLs identify risk. Low TRLs are more risky than high TRLs. TRLs also identify the current status of the technology, and to raise the TRL, there are a clear set of actions that must be accomplished. So effectively, TRL analysis identifies and prioritises the next research actions for the product. Our approach to the TRL analysis is to be conservative. On the supply side, we assess the TRL in terms of how the technology is implemented in our product concept. On the applied side, we assess the TRL as it would be for the stakeholders' application of the new photonics product. We aspire to having high TRLs on the technology side of our value chain analysis. And for impact, we usually look for opportunities where there's a mid-range TRL on the application or buyer side of the value chain. The TRLs are widely known, and I list them here with the questions that we typically ask. The highest values to which we assign a yes answer defines our TRL. For instance, if we look at TRL 8 and an enterprise tells us that their technology is at this TRL level, this would suggest that the end of the system development is completed. We would challenge the enterprise as to who qualified the system, whether they were independent, what is the rigour that was involved in that analysis. If on that probing the answer turns out to be no at this TRL 8 level, we would look to see if the technology is TRL 7, 6, 5, and so forth. The fourth step of our value chain analysis is to calculate the innovation potential. The innovation potential assesses the entire value proposition generated in stage 2 on a 9-point scale, determined by a series of probing questions, which we have derived that gauge both the technical and market potential of the new product concept. Questions like, how much is the technology suddenly possible, and to what extent is the innovation desperately needed, probe both the hard and soft barriers to scalability, as well as the basis for exploiting the innovation. The innovation potential identifies quality product concepts as well as highlighting areas where changes will improve the overall impact of the photonics product concept. In the fifth step of our value chain analysis tool, we introduce the different stakeholders on a system model. Our approach is to take selected stakeholders, perhaps those who have the most appropriate TRL, the highest innovation potential, the best stakeholder relevance score, and to assemble these on a specific model of the product system. I've already described the system model, and it is presented here again. Essentially, what we're trying to do with the system model analysis is to develop a well-synthesized system with a number of key stakeholders so that we can embark on the trajectory of the S-curve for scalable innovation. So in summary, Our value chain analysis tries to answer key questions that researchers, microenterprises and SMEs are challenged with once they have conceived a new product concept. The first question we posed is, how do photonics SMEs get to know the non-photonics field of application? We believe that our value chain analysis helps photonics SMEs do this by completing a structured set of tasks in the value chain analysis tool. The iterative application of this tool helps to further refine and define the product for best impact. The second question we asked is, what is the value of the photonics concept in the non-photonics field of application? Our tool focuses on specific value propositions. We assess those value propositions as to which is of greatest value to the enterprise proposing the product concept. The tool establishes value propositions for the entire value chain. Doing this for the entire value chain is very important, as it gives the enterprise or the researchers full view of the application and the potential of their product concept. Another question that we ask is, where should the future activities be directed by the photonics SME? Our value chain analysis identifies gaps in the value chain. It identifies areas where the technology readiness levels are immature, and so our R&D tasks must address those particular areas. Raising the TRLs of specific aspects of the technology from one level to a higher level also helps direct R&D activities. Finally, our tool answers the question, what is the innovation potential for photonics in the enabled field of application? By analysing the innovation potential for each value proposition, and by doing this for multiple stakeholders throughout the different fields of application, and by representing this innovation potential using the innovation potential parameter, we can identify the priority areas for R&D projects. Finally, by integrating selected stakeholders in a system model that is tuned for targeting scalable innovation, we can optimize the innovation potential of photonics-based SMEs. So that, in summary, is our value chain analysis tool. If you would like to find more information, I encourage you to go to the RespiceSME website, where you'll find more detail of this and other tools that are developed to progress photonics SMEs throughout Europe. Thank you for your attention.